Let's discuss a question on theory of machine. This looks to be a nice question. Okay, so you have a beam and you have at the end you have a mass placed at the top of the beam, and also you have a spring which is resisting. Now, first question that should come to your mind is whether the system is series or parallel. I would say this is a parallel system, especially when you consider mass, because what happens in a parallel system, the deflection is same, the load is distributed, right? Like, let's say you have a two spring system, the deflection is same for both the springs, but the total load is distributed, and basically the total load is sum of the loads carried by the spring. So that is what happens in a parallel system, and this system is also in the similar way. Whatever the mass is deflected, so we can say the deflection at the end of the tip for the beam will be same as the deflection of the spring. So both the systems same deflection, and the total load weight, the weight of the block mg will be carried by the spring as well as by the beam. So it will be distributed, the load will be distributed. So as we know that the in all this vibration problem, the basic thing is, assuming that there is no spring, what we used to do, if you have a block, we used to replace this entire system by a beam, by a stiffness which is equivalent to the beam stiffness. So entire in vibration we used to consider a massless beam, but which is elastic, as just a spring. Okay, and how we used to find out the stiffness of the beam, that is equivalent to, if the load is P here, if a point load is applied or load P is there, P can be mg here, which is the case here. Now because of the load at the end of a cantilever, the deflection at the end will be, we know that, how is deflection related? So that so how is deflection? Now this deflection is delta. The deflection in terms of load at P is PL cube by EI. Now this is from strength of materials. For all this cantilever we would derive actually using this M is equal to EI, that formula. So this is the deflection, and going by this logic, the K of beam will be P by delta, and that is 3EI by L cube. So that is the stiffness of the cantilever beam when the load is applied at the end, and this is the stiffness at the end of the cantilever beam. Remember that. So now in the given problem, I can replace the beam by this spring mass system with K beam is the stiffness, and another spring is given, which is K infinity. So this is fixed, and this entire mass mg is acting like this. So as is the case in the vibration problem, we have replaced a beam with the equivalent spring of stiffness 3EI by L cube. Now this is a parallel system, and therefore the frequency is given by root K by M, and root effective stiffness by M. So what is effective stiffness for a parallel system? It's adding both the springs. Okay, so root KB by K. Now KB is 3EI by L cube plus K by M. Now EI is the flexural rigidity, which value is given as 1, and length of the beam is also 1, and whereas the spring stiffness is also 1 and the mass is also 1. So this is just most of the things are 1 here. So root 4 is the thing, this is 2. Now what is asked is frequency in hertz per second. So that is linear frequency is asked, that is omega by 2 pi, which is 2 by 2 pi, it is 1 by pi. So 1 by pi cycles per second, that is hertz actually, 1 by pi. So C is the answer. Okay, so this is a very simple problem. Only catch here is you have to replace beam by an equivalent stiffness, and you should know how to calculate that stiffness from strength of materials, deflection of beams. Thank you.